Okay, how's everybody today? Doing well. It is Friday. Okay, that's always a good thing. Well, we're going to go ahead and start parametric equations today. Just a few things before we get started. Remember on Monday, what's due? Okay, the homework's going to be due on Monday. How's that going so far? The hyperbolas. Anybody finished it? Okay, almost. Okay, not quite. Okay, so if you do have any questions, come on in Monday morning. Remember, next week's going to be an unusual week because Tuesday, Wednesday, Thursday, that's STAR testing. So they're going to be late start days if you're not testing. I believe it goes Algebra 1, then History, and then Science. Okay, is the order? Okay, if you're taking any of those. But, we're getting down to our last couple weeks of school. We got 3 weeks left. Excuse me. So we're not going to worry about having a quiz or anything like that next week. So I'm going to push the test to the next week. So actually 2 weeks from today is when you'll have your second exam. It's going to be on May 17th. All right, so I know for sure it's going to have parametrics on there, but that's also 2 weeks out, so I don't know if I'm going to put conics on there. It depends on how far we get with polar coordinates. I may end up having to put some conics on there anyway just to make it a bigger test. All right. Any questions about what's going to be happening? There will be a final. So that last week, I'll go ahead, get some kind of final together, get a review for you. It'll definitely be multiple choice, something similar to what happened around Christmas, so that I can get it graded and boom, be done. Okay. And I think we talked in here yesterday about this. Anybody who might be missing for if you're leaving early or if you're going to be for a test, anything of that nature, what I generally suggest is just let me take the 4th, 5th, and 6th week's grades, average them, and put that in as your final exam grade. The only other alternative would be you have to come in sometime that following week and go ahead and take the test. Okay, so as we get closer, I'll let you guys go ahead and decide what to do about that. There is one other thing I need to go ahead and mention. Today, during 8th period, we are having another fire drill. Okay, the reason we're having them back-to-back, we had one last Friday. Okay, well, that was April's fire drill. We're now in May, so we're going to go ahead and get May's done. So we're going to have another fire drill. Hopefully it's not going to be raining at that time, but, probably about, I don't know, whatever time he comes on, 40, 45-ish, Mr. Anderson to come on, talk about it again, and, there you go. So you'll take your stuff with you and just go and have a nice weekend. Okay. Any other questions? All right. Well, if you weren't here yesterday, go ahead and pick up a copy of the packet over there. There should be some on the door, but I passed these out yesterday. Anybody have the opportunity to read that front page? Kind of see how we're doing. So a few people did. Good. If you didn't, I'm not going to go ahead and read this to you, but I did go ahead and summarize it. Okay. So what are we talking about here? Parametric equations describe the horizontal and vertical movement of an object with separate equations in terms of time. So the normal equations we deal with only have the variables x and y. We're going to refer to those as rectangular equations, the ones we're accustomed to. Now, when we're looking at those types of graphs, we really don't see the whole story. Like, for example, we could see, the height of an object at a particular time, but what about the horizontal distance at a particular time? That's where parametric equations are going to come in, okay? You introduce this third variable t, which is representative of time. We call that a parameter. And in order to get the ordered pairs for a graph, x has its own equation in terms of t, and y has its own equation in terms of t. So basically, x equals f of t is going to tell me how far the object's moved at a particular point in time, okay, horizontally. Y is going to tell me vertically the height of an object, again, at a time t. Now, both of these work together to give you the graph that you would have gotten under normal circumstances, the rectangular form. Okay, so an example of this is actually on this page. All right, if you go ahead and take a look, this third graph right here, this is what we refer to as your rectangular graph. So y equals, some kind of x transformation. X is the horizontal, y is going to be the vertical, and in fact, these are provided at the very bottom of this page. So if I were to look down here, This is representing graph number 3. Okay, so my parametric equations, and there's always a pair, are the first 2 graphs. So like the middle one, that's x equals 30 square root of 2t. So if I were to come back over here, this is x equals 30 square root of 2t. So see, your horizontal axis is time, while the vertical axis is x. So that other parametric equation, y equals, that's this first one right here. So you have a horizontal axis in time, and y is your vertical. So see, at any given time, you can find the vertical height based on that one parametric equation. On the other parametric equation, at any given time, you can see the horizontal distance that an object has moved. Now, in here, I'm only going to be doing basically just a brief introduction of parametric equations, but they have a lot of applications in both physics and calculus. All right. So how do we go ahead and work with these? Well, I'm glad you asked. We're going to basically take the lesson and we're going to break it up into 3 parts. The majority of what we're going to do today is we're going to be given a pair of parametric equations, and we want to practice graphing them. I want you to feel comfortable getting the graph, but also finding the orientation. The orientation is the direction that your object is moving. Okay, and you're going to label it on your graph with little arrows, and I'm going to show you how to do that. Okay, then on Monday, we're going to do one of those today, but on Monday, I'm going to go ahead and show you how to take a pair of parametric equations and rewrite them to get the rectangular form. Okay, the form we're accustomed to. And then another day, I'll go ahead and take a rectangular form, and we'll go ahead and break it apart into parametric equations so that we're covering all of our bases. And then, we'll finish up with some real-world applications, all that good stuff. So this information right here, this is going to be for today. How are we going to graph these? Well, step 1, we're going to choose values of t. And it's really, really important that we go from low values to high values. Okay, starting with a low value of t has me plot the points in a particular order, and that helps me with the orientation. Remember the direction that the graph is going. Substitute each value of t into each parametric equation to get the xy coordinates. So x parametric will give me the horizontal value, and then y will give me the vertical. Combine those. And then 3, plot the points xy in order of increasing t and connect with a smooth curve. Okay. Did I need to leave this up here for a few more seconds for anybody to copy that down, or we feel we're good? Okay, a few more seconds? Okay. Or you can do like first period. A lot of people took just a picture of it. You can do that if you want to. All right, so I'm getting a photo opportunity here. Okay. Okay, there you go. Make sure we get some good photo. Oh, there we go. Still doing it. Yeah. Or then I can do the thoughtful pose where I have my. Okay. Chewing on the end of my glasses. There you go. Okay, so let's go ahead and do an example. Okay. So let's go to the next page. All right. So A, sketch the curve given by each pair of parametric equations over the given interval. So we have x equals t squared plus 5, y equals 1/2 t plus 4, and we're given an interval from -4 to 4. Now, I can choose any values on this given interval, but my advice is just to choose values that are going to be really easy to evaluate. I mean, you don't have to go ahead and make this any more difficult than it needs to be. So you'll notice I've got a 3-column table here, t, x, and y. Okay, so column t are just the integer values from my interval. So -4, -3, all the way to 4. So what I want to do one at a time, I'm going to plug those values into each of the parametric equations. I'm going to get all the x's, I'm going to get all the y's, and together those provide me ordered pairs on my graph. Okay, so let's start with the first one. So x equals t squared plus 5. So if t equals -4, so x would equal -4 squared plus 5. And that would give me what? 16 plus 5, 21. There we go. Okay. And then I would just continue that. So this part's really easy. I mean, it's just function notation, substitution, and evaluation. So let's see. -3 squared plus 5. 14. -2 squared plus 5. -1 squared plus 5. 6. 0 squared plus 5. 5. And then what are you noticing as we go into the next set? Yeah, it's just going to give me the same values. I mean, it makes sense we have symmetry because it's a quadratic function we're plugging into. So 1 would give me 6, 2 would give me 9, and then we back to 14 and 21. Okay. So I've taken care of the x parametric equation. Well, I'm going to take those t's now, and I'm going to plug them into the y parametric equation. 1/2 t plus 4. So starting with -4, y equals 1/2 times -4 plus 4. And what would that be? That would be 2. And on this one, I know that you guys really, really like working with decimals, but just to kind of keep things going a little faster today, or fractions, we'll just use the decimals. Okay. So if I plugged in -3, half of -3 plus 4. Oh. Now remember, that's a negative. -3/2 plus 4. So it'd be 2.5, right? Okay. Did anybody want me to work that out just to show you? Or good? Okay. Well, what would happen if I plugged in a -2? Half of -2 plus 4. 3. Half of -1 plus 4? 3.5. Well, you'll notice this parametric equation for y, it's just a linear function, right? Mx plus b. So you'll notice the slope is 1/2, so the pattern, my values are just increasing by a half each time. Okay, so what would 0 be? 4, and then just give me the rest. 4.5, 5, 5.5, 6. Okay. And now on the following examples, I went ahead and added a 4th column because I really want to emphasize the point that plugging t into both of these equations gives you an ordered pair. They work together. So when time is at -4, and right now don't worry about the fact that it's negative because we don't think of it in terms of that, but don't worry about that right now. We're going to go ahead and say because x gave me 21, y now has 2, we have the ordered pair 21, 2. And then we have 14, 2.5. And then we can just use all those as we go down. Okay. Now, for the x-axis, we just have to make sure we can get to 21. So let's say this is 0. I'm going to go ahead and count by 2s to make that happen. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 ought to do it. Okay. Now, I only have to get to 6 on the vertical. Okay, so I'm just going to go ahead and count that by 1s. I mean, if you want to count by 2s, you can. Just makes the graph a little easier to see. So 1, 2, 3, 4, 5, 6. Okay. Now here comes the most exciting part of this lesson, plotting points. Okay, so give me a few seconds. 21, 2. So 21, 2 would be right here. Then we have 14, 2.5. Then we have 9, 3. Then we have 6, 3.5. Then we have 5, 4. Then we have 6, 4.5. Then we got 9, 5. Nope. Put that in the wrong spot. 9, 5. Then we got 14, 5.5. And finally, 21, 6. There you go. Now remember, plotting points found from the parametric equations would give me the same graph as if I had the rectangular form. So if I were to find the rectangular form based on these parametrics, it should be a parabola opening to the right. Okay. Graphing the parametrics, graphing the rectangular is always going to give you the same thing. Now, let me ask you a question. I am going to connect these with a smooth curve, but why would I not want to do this? Why would I not want to continue to the right? It's limited. Remember, our interval is only going to have me go from -4 to 4. So those are the only points that we have corresponding to -4 and 4. So I have to take those off. Okay. Now, there's the graph. That's easy enough, right? Not too bad. Now, one other thing, because we're graphing parametric equations, we want to know the direction that the object is moving. Okay, so this is why we're always going to start our tables with the smaller value of t's and get larger. The order in which you plotted these points That's the direction you're going to go. And what you're going to find on a lot of these parametric equation graphs is that they're numbered. The very first point we got was 21, 2. So I'm going to label that with a little 1. The second point was here, then third, fourth, fifth, sixth, seventh, eighth, 9. So you see how I'm going from 1 to 2? That's the direction I'm going. You always point it in the direction that your points are flowing. Okay, so I know that I'm going to travel all the way around. And see, when I get here, I'm going to curve back and go the other direction. Okay, that's what we call the orientation. That's the direction that the object is moving. So it's a little different. You know, when you normally look at a graph, typically you're going to read it from left to right because positive is where you first go to. You know, the x values are increasing, but that isn't always going to be the case when you're dealing with parametric equations. Okay, so kind of think about it like this. You remember way back in the day when you guys were young and you had those little picture books? You had 1, 2, 3, 4, 5, 6, 7, 8. And so you would go ahead and connect them in order. 1, 2, 3, 4, 5, 6, 7, 8. And then you get some kind of picture like a kitty. That's essentially what we're doing here. Okay. That's a cool cat, right? Yeah, yeah. It's what? Raphael? It's a very rare, what? It's a carrot? How is that a carrot? Okay, you could say that. Okay. I'd be very interested to know what kind of a picture book that comes out of. You know. Look, mommy, a tooth. I was making a joke. Yeah. You'll laugh later. Okay. But there you go. Any questions? Okay. Okay, well, let's go ahead and try a few more of these. Now, there is one at the bottom of your page here. You have different parametric equations. I'm not going to worry about doing this one because a couple things. You're going to find that this will give you the exact same graph. So rectangular forms, the original equations we work with, they're not just limited to one pair of parametric equations. You can have multiple different parametric equations, and it changes nothing. Just depends on how you choose to write your parameters. Okay. The only difference here between this one and the one we just did is how fast the object is moving, the speed at which it's moving. So that's an aspect of parametric equations I'm not really going to focus on. I don't think we need to worry about that. But I do want to go ahead and practice a few more graphing parametric equations. I want you to feel comfortable with that today. Okay, so if you want to put this on just an extra sheet of paper, or if you want to fit it someplace on your packet, you know, wherever you want to. Here's another example. Graph x equals t plus 3 and y equals negative t squared. And it looks like we're going to have an interval from negative 2 to 2. Okay. All right, so you'll notice I went ahead and put in 4 columns this time to my t-chart because that last column is going to be the ordered pairs, and you don't have to do that if you don't want to. Excuse me. Don't know you. Okay. There we go. All right, so the first column is going to be t. Then the second will be the x equation, t plus 3, and then y equals negative t squared. And then, of course, this last one right here is the xy coordinate. Okay. I'm including that in there because I really want you to make the connection that these two equations, the parametric equations, are working together to provide you those ordered pairs. Okay. The same graph as if you had the rectangular version. Okay, well, again, let's just choose the integers between negative 2 and 2. So I'll say negative 2, negative 1, 0, 1, 2. Okay. And now to finish filling in the table, it's just, you know, substitution. Negative 2 plus 3. Okay, 1. Negative 1 plus 3. 2, 0 plus 3, 3. And you'll notice, I mean, it's just a linear function with a slope of 1. So if we're going by consecutive values of t, then we should get consecutive values for the x. Okay. Now, you do want to be careful on this one. Y equals negative t squared, you do want to follow your order of operations. So does that mean the negative or the squared first? squared first. Okay, so if I want to plug in -2, y equals -t squared becomes -2 squared. Now this right here gives me +4, but then you've got the negative waiting on the outside. Okay. All right. So Miriam, what would I get if I plugged in -1? Oh, you're taking a quiz. Okay, Raphael, would you help her out, please? You would get -1. That is exactly right. Okay. Whoop, erase that. If I plugged in 0, I'm going to get 0 because 0 is neither positive nor negative. Zach, what would I get if I plugged in 1? Oh, Trey, please. So -1 squared. It would be -1. There we go. Because 1 squared, and then we multiply by the negative. Okay. And Shayna, finish it up. What if I plugged in a 2? -4. And again, we see that symmetry because we're using consecutive values, so we should be able to see that in the quadratic. Okay. And then here's my ordered pairs. Remember, the parametric equations are working together to create the graph. Okay, it's just that the parametric x equation gives me the horizontal distance with respect to time. The vertical distance with respect to time, comes from the y parametric equation. So this is 1, -4, 2, -1, 3, 0, 4, -1, and finally 5, -4. Okay, so let's go ahead and plot this. So we got to be able to get out to 5 and then -4. So 1, 2, 3, 4, 5, -1, 2, 3, 4. Okay. Now for this one, because I've already kind of explained the orientation, as I plot the points, I'm going to go ahead and number them. The smallest value of t we had was -2, so that means that 1, -4 was my first ordered pair. So then 2, -1 is the second. Then 3, 0 is the third. Then we have 4, -1. That's the fourth. And finally 5, -4. That was the fifth one. Okay. So I'm going to go ahead, connect those with a smooth curve. So eventually I'm going to show you how to do this, but if I were to regain the rectangular form based on the parametric equations, I should be ending up with what? The equation of a parabola that opens down. Okay, that's exactly right. Now, where's my orientation? What direction am I going? I'm going left to right. See, because I went point 1 here, point 2, I'm going to place the arrows in that direction, showing how I plotted them. So then another arrow here, 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 here. Okay, so there we go. Remember, that's the orientation. That's the direction the object is moving. Okay, now let's go ahead and start to play with the interval just a little bit, because I want you to see how changing the interval will change the graph. What if instead of that interval, I just said -2 is less than t, which is less than 2? What would change on the graph? Okay, Aiden says you couldn't have those last 2 points. Instead of closed circles, they would have to be open circles, because I now no longer have equality. Okay. Now, typically, I don't like to write compound inequalities like this, but just for argument's sake, okay, let's say I'm now going to go for this interval. So basically, t is any real number. Okay. So that means the graph is going to continue, right? So this is the time where I could go ahead and draw this, but here's where you want to be careful. Typically, when you go ahead and draw these, people go ahead and put the arrows at the end. Why is that wrong in this case? Because of the orientation. One of them's correct. The one on the right is correct, but for this one right here, I would have to probably start it like that, okay, and then show that that continues around. Okay. Is everybody okay with that? Is anybody having a hard time? Okay. Are we ready for one on our own? Okay. And are we ready to look at something we haven't seen in a while? Trig. Yay. Okay, good old trig. All right, so here are my parametric equations. X equals 4 sine of t. Y equals negative 3 cosine of t. Excuse me. And I want to put this on the interval between 0 and 2 pi. So again, choose values that are going to make it easy for you to evaluate. You just want to go ahead and get enough points to get that smooth curve, right? So we're just doing one revolution on the unit circle. So I'm thinking about particular locations. What do we call it when the terminal sides stopped on an axis? Quadrantals, there we go. So for my values of t, between 0 and 2 pi, let's start at 0. What's another quadrantal if I'm rotating counterclockwise? Pi over 2, then pi, 3 pi over 2, and then we get to 2 pi, which is coterminal with the 0. Okay. Now remember, because I chose quadrantals, when you evaluate the sine and cosine, you're only going to be able to get 0, 1, or negative 1. And then, of course, you'll multiply by, the 4 and the negative 3, depending on that. Okay. So I'll give you time to do that while I write this out. So this is x equals 4 sine of t. This is y equals negative 3 cosine of t. And this right here would be your ordered pairs x, y. Now, these are parametric equations to a function that we are actually already familiar with. So you might be surprised when you see the graph. Okay, so I'll give you a little bit of time to do so. All right. And while you guys are doing that, I'm going to pass back your papers. I'm sorry? Oh, no, it's not tangent. Okay. Okay, so I know I asked this the other day, but so does Xavier not go here anymore? Does anybody know Xavier?
I haven't seen him at all.
He just disappeared, and I haven't gotten an answer as to where he's going. So, no, anybody in here friends with him? Nobody in here is friends with it. You know who I'm talking about, right? Okay. 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 All right. I don't know. He's just gone. And see, normally that's not anything weird, but he's also gone from teams too. So he's off the grade books. I don't know.
He might have graduated.
Maybe. Okay. Ethan's not here. Kyle. Jasmine. Enzo. Scout. Aiden. Yeah. Okay, cool. Check out Marcus. Okay. Xavier. Jacob. Alex. We have Erica. Jane. Raphael. Zach. Okay, now Susie. Britt. Teach. Stephanie. Bethany. Connor. Shayna. Dylan. Jack. Okay, Zach. Jack. Sylvian. Jack Williams. That's it. Okay. Is everybody about ready, or we need another minute or so? Okay. Hey. Then you would close it. It would stay closed. Okay. Well, let me go ahead and catch up to you guys. The x's, 4 sine of 0. That would be 0. 4 sine of pi over 2. Okay, 4, because sine of pi over 2 would be 1. And then what about 4 sine of pi? 0, 4 sine of 3 pi over 2. Negative 4 and 2 pi would be coterminal with 0, so that would give me a 0 as well. Okay. Does anybody want me to go back and elaborate on those, draw a unit circle? Are we okay with that? Okay. All right. What about y equals negative 3 cosine of 0? Negative 3 cosine of 0 is 1. And then negative 3 cosine pi over 2, 0. Negative 3 cosine pi, 3. And you'll notice the pattern. So you plug in, now you get 0, and then you're all the way back around to negative 3. Okay. So filling in the chart pretty easy. No problems there. And then we have our ordered pairs, 0, negative 3, 4, 0, 0, 3. Then we have negative 4, 0, and we have 0, negative 3. Okay. So let's see here. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay. And we go ahead and plot them. 0, negative 3. Well, that is the first point. And we have 4, 0. 2, 0, 3, that's the third, negative 4, 0 is the fourth, and then all the way back around 5 and 1 are going to be the same. Okay, so these are the parametric equations for a what? This is an ellipse, yes. Okay, you get an ellipse, very good. Now, am I forgetting anything? The orientation. Okay, so Raphael, am I going to draw the arrows pointing clockwise or counterclockwise? Counterclockwise. Again, the direction is going to go from the order that you label those points. Since I'm going from 1 to 2, I'm going to go around in this direction. Remember, that's the orientation. That's the direction of the object. Okay, and there you go. How many people got that right? Okay, so that's a decent number of hands going up. Is there anything I can do to help? Is it for something from the table? Is it part of the graph? Or was it just not enough time? Excellent. Okay. All right. Well, let's start playing with the interval again a little bit. What if this exact problem had the interval 0 is less than or equal to t, which is less than pi? How would that change my table? Okay. Well, you'll notice I can only go to what? Pi, so both of those would be gone. But how would it change it graphically? Only the right side would continue to exist. So it would disappear over here. But I'm also forgetting something. There you go. That third point, the 0, 3, I'd have to have an open circle there. Okay. So again, you know, your interval is going to be really important. Okay. It can definitely affect that graph. Right? Any questions? Is anybody having a hard time? No? Okay. Well, that's the graphing section. You know, we'll definitely go ahead and do another one come Monday. But I want to go ahead and at least show you, okay, now that we have parametric equations, let's say I want to go ahead and get back to the original rectangular equation that gave me these. Okay. So here's an example. Let's have a little more room here. It says, write x equals negative 3t and y equals t squared plus 2 in rectangular form. So I only want one single equation with y and x. Now, typically what I like to do is, well, I'm getting a little ahead of myself. You're going to use substitution in order to do this. Okay. Now, you're going to solve one of the parametric equations for t. It does not matter. Okay, t equals whatever expression, and then you're going to substitute that into the other parametric equation. Now, what I was saying just a moment ago, I prefer to take the x parametric equation, solve that one for t, because your ultimate equation is going to be y equals, you know, something with x. That's typically how we go ahead and write ours. If you go ahead and do it where y is plugging into x, well, then it'll be x equals something in terms of y. Okay. I'm actually going to go ahead and do it both ways to show you that it's equivalent. So let's start with the x. How would I solve x equals negative 3t for t? Okay, let's divide by negative 3. So I can immediately see that negative 1/3 x, or negative x over 3, equals t. Okay. I'm going to take that expression and I'm going to plug it in the other parametric equation for t. Okay. And then when I simplify, well, that's going to be my rectangular function. So let's see here. Y equals t squared. That would be y equals negative x over 3 squared. Let me write that x a little better. And then we have plus 2. Okay. So what is a negative 1/3 x squared? X squared over 9. So y equals x squared over 9 plus 2. And there you go. That would be my rectangular graph. Okay. Now remember, this is just one pair of parametric equations that could give me this graph. It depends on how you decide to define your parameter t. There are different pairs of parametric equations that can be used for just one rectangular. This is not just one pair, okay? All right, well, let's try the other direction. And hopefully we should get the exact same function. So y equals t squared plus 2. Okay. How would I solve that for t? Okay, so let's subtract the 2. So y minus 2 is equal to t squared. Okay, take the square root. Okay. So that is going to give me t, but what am I forgetting? Plus and minus. Okay, so is everybody okay how I got the second equation solved for t? Well, I'm going to take that expression and I'm going to plug it in the other parametric equation. So x equals negative 3 times t, which is our plus minus square root y minus 2. So I can actually go ahead and multiply those. The negative times the positive and the negative is still just going to result in a positive negative. So x equals plus or minus 3 square root y minus 2. Now, typically what you would do is you'd go ahead and divide out that coefficient before you'd go ahead and square it. But actually here, the order doesn't matter. I'm just going to go ahead and square it because I want to go ahead and get rid of that plus minus. So if I do it this way, what do I have on the right side? 9. And then we just have y minus 2. Because remember, this square is simply going to cancel with that radical. So see, now I can simply divide the 9 over. X squared over 9 is equal to y minus 2. And then what's my last step? Subtraction? Add 2. So this would tell me that y equals x squared over 9 plus 2. And isn't that exactly what we got the other way? Okay. There you go. So you can do this however you want. It is completely up to you. But I would say when you're asked to give the rectangular form, let's make sure it's always y equals x. Okay, let's always go ahead and have it as y as a function of x, just so we all get the same answer. Okay. Questions? How are we doing? Parametric equations. Are they not as bad as you might have thought? Nope. Okay. All right, well, that is as far as the other classes got, so we will stop there today. Don't forget what's due on Monday. Okay, homework. Okay, don't forget about that homework. Okay.